2, 3, 4, 5, 6, 7, 8. I love doing math. I love doing math. 1, 2, 3, 4, 5, 6, 7, 8. I love doing math. I love doing math. Hey, math is so easy to me. So easy. Count it up like.
Hey everybody, welcome to today's math lesson on one of my favorite topics, algebra. We are going to pick up where we left off last week, talking about solving equations. Before we do that though, I want to review an important concept that we began to discuss last week. So you may remember that we talked about inverse operations, and inverse operations are opposite one another. For example, addition and subtraction are inverse or opposite operations. So I want to show you something. If we take a given number, in this case we'll take the number 5, and if we add 3 to it and subtract 3 to it, let's see what happens. 5 plus 3 equals 8. 8 minus 3 equals 5. So if we add and subtract the same number to 5, we are left with 5. That's because these operations are opposite one another. If we add 3 and then take away 3, we're left with where we started, which is 5. Today we are going to be talking about equations that have multiplication, algebraic equations that feature multiplication. So it's important that we review what the inverse operation to multiplication is. And you might remember that the inverse operation, or the opposite operation of multiplication, is division. So let's start with the same number, 5. And again, if I take 3, this time we'll multiply 5 by 3, and then divide 5 by 3. Let's see what happens. 5 times 3 is 15. 15 divided by 3 equals 5. So if I multiply 5 by 3 and then divide 5 by 3, I'm left with my same starting point. I'm left with 5. Multiplying by 3 and dividing by 3 are opposite, so they essentially cancel one another out, so we are left with what we originally started with, in this case 5. That's going to be very important to remember as we begin solving these multiplication equations today. Here's our first example. 7x equals 21. I want to draw your attention to something very important first. You'll notice that in this problem, we don't have a symbol between our number and our variable. We just have 7x. There's not an addition, a subtraction, a multiplication, or a division sign. When we don't have a symbol, when we just have a number and a variable right next to each other, it means we're doing multiplication. So we're taking 7 and multiplying it by x. We briefly talked about this last week. Okay, let's go through these 3 steps in order to solve this equation. And these are the same 3 steps that we used last week when we were solving equations that had addition and subtraction. Same 3 steps, even though this equation features multiplication. So step 1 tells us to determine the variable we want to solve. In this case, it is x. Step 2, use the inverse, which we know means the opposite operation, to isolate the variable. Okay. So the inverse operation of multiplication is division. So instead of multiplying x by 7, I'm going to divide by 7. And whatever I do to the left side, I also do to the right side. Well, multiplying by 7 and then dividing by 7 would leave us just with x. That's what we talked about before we solved this problem. So I'm left with just x on the left side. And I know that 21 divided by 7 equals 3. So I think that this is my final answer. However, I don't know for sure until I check it. So instead of writing 7 times x, I'm going to write 7 times 3. Okay, this is where it gets a little bit confusing with the x's. This is a multiplication x. This is our variable x. So you can see I made a little tiny x to represent multiplication so that we don't get it confused with our variable. All right, and based on our original equation, 7 times 3 should equal 21. Well, 7 times 3 does equal 21. You could use a calculator to support you. So we know that x equals 3 is in fact our final answer. Okay, let's look at our second problem. We have a lot going on in this problem. First, we have a fraction. And second of all, you might notice that our variable is on the right side of the equal sign instead of on the left side of the equal sign like it was in problem number 1. Well, personally, I like to solve for a variable when it's on the left side. That makes a little bit more sense to me. So I'm just going to flip the order here. I'm going to write 1/2 y equals 6. Okay, and we can do that. We can flip the left and the right side of the equal sign, okay? Because they're equal to one another. It doesn't matter what's on the left side and what's on the right side as long as they stay the same, okay? So even though we have a fraction, we still are going to follow these same 3 steps. First, we need to determine the variable that we want to isolate. In this case, it is y. Then we need to use the inverse operation to isolate it. So instead of multiplying by 1/2, I'm going to divide by 1/2 on both sides. And we know that by multiplying by 1/2 and dividing by 1/2, we are just left by y on the left side. However, on the right side, I have 6 divided by 1/2. And that's going to require us to apply what we learned about fractions a couple weeks ago to solving this. So bear with me, you've totally got this. It's just going to take some extra steps. So we have 6 divided by 1/2. Well, you might remember that when we are dividing fractions, our first step is to write whole numbers in the form of a over b. And we do this by adding a 1. So now we have 6 over 1 divided by 1 over 2. We have 2 numbers written in the form of fractions. However, when it comes to dividing fractions, instead of dividing, we're going to multiply by the reciprocal of the divisor. This is the divisor, and the reciprocal we find by flipping the numerator and the denominator. Okay, this is all review. So I'm going to rewrite this problem as 6 over 1 multiplied by the reciprocal of the divisor by 2 over 1. Okay, now when I do that, I multiply numerator times numerator, which equals 12, and denominator times denominator, which is going to equal 1. So I have 12 over 1, or I can just write it as a whole number as 12, okay? So I think that my final answer is y equals 12. However, I don't know for sure until I've checked it. And we just went through a lot of steps, so it's important that we check this problem. All right, so I'm going to erase this so that we have some room to do step 3. So I think y equals 12, okay? That's what I'm checking. So I'm going to rewrite this equation. I'm going to write it as y, 1/2 y equals 6, and then I'll plug in 12. So I have 1/2 times 12 equals 6, okay? And I'm going to follow my rules of multiplying fractions in solving this. So I'm going to rewrite this as 1 over 2 times 12 over 1. And if we do this correctly, we should get 6. So let's see if that's true. I'm going to compare cross factors, because remember, I'm following the same rules of multiplying fractions that we learned a few weeks ago. And 1 and 1 can't be simplified because they're the same number. They're already 1. But 2 and 12 can be simplified, and we can divide 2 by 2, and that would equal 1. And we could divide 12 by 2, that would equal 6. So what I would get here is, well, let me rewrite this. I would get 1 times 6 over 1 times 1, which would equal 6 over 1, which we can rewrite as a whole number as simply 6. Okay, so that's true. 1/2 times 12 does equal 6. That's what our equation says our equation should equal. So we did this correctly. Y does in fact equal 12. Okay, it is time for our third and final example problem. You'll notice that this problem has a decimal in it, but even though it has a decimal, we'll still follow these same 3 steps. So we have 7/10 multiplied by m equals 42. Step 1 tells us to determine the variable we want to isolate. So in this case, it's m. I'm going to circle it. Next, we need to use the inverse operation to isolate this variable. So instead of multiplying by 7/10, I'm going to divide by 7/10 on both the left and the right side. Well, we know that when we multiply by 7/10 and divide by 7/10, we're just left with m. Now use a calculator to support you for this computation. 42 divided by 7/10 equals 60. So I'm pretty sure that my answer is m equals 60, but I don't know for sure until I've checked my answer with step 3. So I'm going to write 7/10 multiplied by 60, and if we've done that correctly, it should equal 42, which it does. So my final answer is n equals 60. Here are those 3 steps that we've been using to solve our equations today. You might want to pause the video on this screen when you're doing your independent practice so that you can use these steps to guide you. Have fun!
1, 2, 3, 4, 5, 6, 7, 8. I love doing math. I love doing math. 1, 2, 3, 4.